Hi and welcome to Concept Based. I'm John Hepworth, and this question is possibly going to be the longest question that I ever have on this channel because it's one of these extremely long, wordy questions that's in this topic, which is trigonometry. Well, for 11 extension, further trigonometry, and then we're in the trigonometry in 3 dimensions. So if the trigonometry is in 3 dimensions and it's a worded question, it's quite complex because it has to give a long description to advise where all of these 3-dimensional properties come from. And then even there can be multiple parts then to solving the question. I've actually made this question smaller by just asking you to solve the last part of the multiple steps because that's going to require us to go through step A, step B to get to step C anyway. So what's my teaching method on questions like this? Well, as you know, I've been saying the whole time across all my videos, draw something. Now, obviously you're going to draw something in this question because if you don't draw something, then how are you ever going to visualize what it is exactly that you're after? So I know students will draw something. So then the question is well, how do we draw something? Now that's extremely different for a range of different students because some students very much struggle with 3-dimensional visualization, whereas other students find it quite intuitive. So based on how they feel about that, they might feel more comfortable drawing something in different ways. So for example, someone who's very good with 3-dimensional visualization and is possibly even artistic might draw something in an isometric style that looks almost real in their graphing. Someone might draw it sort of vanishing point style and so forth. But let's assume that you're not an art student. And let's assume that your 3D visualization ability is, let's say, average. So what would I do to try and teach the average student or even the student that's struggling with drawing these types of drawings? Okay, so let's get into it. A ship travels 12 kilometers due north from the point O, so the origin, then changes direction and travels 8 kilometers on a bearing of 40 degrees, true bearing, because 3-figure bearing there. A helicopter is flying directly above point O at a height of 5 kilometers. Determine the angle of elevation from the ship to the helicopter. So we're looking back to the origin, but up at this helicopter. Okay, so we're going to draw something. Now, before we even draw something, what we want to try and do is think, well, what information on this drawing that we draw is going to help us solve this question? In the end, we're doing a determine the angle of elevation question. So we can determine an angle of elevation if we have 2 sides of a right angle triangle, or we could be doing it using some maybe sine rule or cosine rule. But in this one, it's just a straight up trig situation. We need to get 2 sides of a triangle. And so we know the height of the helicopter, the 5 kilometers. So what we're really looking to find is the distance that it is away from the ship at its final location. So that's what we want to make sure on our diagram we're heading towards and we have some space for. Now, I'm going to delve into this in a way that aims towards that average to a lower average student in terms of understanding 3 dimensions and saying this. Sometimes it's better to do 3-dimensional questions in 2 dimensions. So if I was going to start this question and just deal with the first 2 dimensions, I can just deal with the ship sailing. The ship is just all in 2 dimensions, so let's do that. Okay, so we're drawing a ship starting at an origin and going 12 kilometers north. So I'm just drawing this. Now, straight away, you might be having issues with 3-dimensional visualization. You might be like, didn't you just draw up from the origin to where the helicopter is? No. I'm drawing this in 2 dimensions as I'm looking down on the ocean. And so I'm keeping this z-axis, this up to the helicopter, out of the question. I'm just looking down at the ship sailing. So we do this for 12 kilometers. And then we go on a bearing of 040 degrees. So I'm going to draw that in. So this is a 40-degree angle from true north, 040 degrees. And that distance I travel for is 8 kilometers. Okay. So this is the information that I have just about the ship and where it ends up. So what I want to do is I want to find out information that's going to be in the triangle of the helicopter later. So I might just put that on here of what we're aiming for. So this helicopter, and I'm going to draw the third dimension here. The helicopter is 5 kilometers up in the air. And then it's going to look down at where the ship ends up. Now you may, if you struggle with 3 dimensions, you may just be looking at that and going, what? He's just drawn like a parallelogram or a rhombus. So this is the ground angle back to the helicopter from the ship. And that's a right angle going up in the air. The only reason why I'm drawing this is to clarify for you that I need two dimensions in the final picture. This helicopter is 5 kilometers up in the air. I've got this one. And I just need this unknown, and I can get into this helicopter triangle. Okay, let's get rid of that so it's not confusing. So essentially what I need is I just need this third side of going back to the origin from the ship. This is where the ship is. And if I can get the length of that side, I've already got the height of the helicopter, and I can create the helicopter triangle. Okay. So that side now is going to take us into all of our mathematics advanced rules that we've learned for non-right angled triangles, so sine rule, cosine rule, and so forth. So we have to decide what one is this one. Well, we've got this included angle here. That's going to be 140 degrees. I've not left myself a bunch of space in here. That's 140 degrees. And so if we've got two angles side by side and we're looking for this third side, then hopefully you can identify that we're going to be using the cosine rule. So c squared equals a squared plus b squared minus 2ab cos c. So c squared equals, so it doesn't matter which one you do as a or b. So 8 squared plus 12 squared minus 2 times 8 times 12 times cos 140. And then that is going to come out on my calculator. Now I'm just using my calculator in hand. I'm not using an on-screen calculator because it's so much easier to use these hand calculators. So I apologize that what you see is me looking down and entering details into my calculator, but it's just the way it's going to be. That might change on this channel in the future. So when I'm doing cos, I need to make sure that I'm in degrees mode. So I'm checking my calculator that I'm in degrees because I'm about to put 140 degrees into my calculator. And if I've just done some radian calculations and I'm not in degrees mode, I'm going to get this very wrong. So C equals 355. I hope that your brain recognizes that's an outrageous side of a triangle. It can't be an 8, 12, 355 because we haven't taken the square root. We take the square root of the answer and we get an 18.85 kilometer side of a triangle. Okay, so we've got our 18.85 here. As you saw from that other triangle that I drew, that's the base of the triangle. That's the base side in the new triangle. So when I say new triangle, let's now go and draw the new triangle. So now I'm just drawing a ship anywhere. Here's my ship. Here's the origin. And we know that we are 18.85 kilometers away from that origin. Doesn't matter that I've drawn it east or north or west. It doesn't matter. What I care about is the right angle triangle. The helicopter is directly above the origin, so right angle, 5 kilometers in the air. And we are looking back at it from the ship. And we want to know the angle of elevation. So that's in here. So this is just a right angle triangle problem, a standard right angle triangle problem. So it's just your normal trig. So let's call this angle theta. So tan theta equals 5 over 18.85. So theta equals inverse tan of 5 over 18.85. And therefore theta is going to equal, back on my calculator again, shift tan 5 divided by 18.85 equals, and I get an angle of 14.85 degrees. In the HSC, they'll often say to the nearest degree. So I'm going to say 15 degrees of elevation. Okay, so the question is solvable, no problems, right? What's a problem is this bit, okay? Can you draw the original diagram if you're struggling with three-dimensional visualizations? What did I do? I broke it down into 2 dimensions, I drew the ship from above, and just did all the calculations that I could do in those 2 dimensions. I then changed to a different 2 dimensions. I'm not even going to name the axes because that doesn't matter if it's confusing for you. I've now just changed, so now that I'm looking side on with the ship and the origin and the helicopter up in the air, and I now just work in these 2 dimensions. And it generally is the way that you work on all 3-dimensional problems. You really are only ever working in 2 dimensions at a time and bringing it together to form some sort of 3-dimensional solution. So if you are struggling, obviously draw a picture, but what sort of picture do you draw? Draw the most simple one you can. It can be in 2 dimensions. Now I'm going to add like a post note here, PS. If you are a very good 3-dimensional understanding person and you are able to draw these in one hit and work on the diagram, awesome, stick with that. If you were going to say origin 12 kilometers north, change bearing at 40 degrees and go for another, what was it? 8 kilometers? Move your helicopter up 5 kilometers. And then consider that you are trying to calculate this view off this triangle with this angle of elevation. If you can grasp that as what is going on in that picture, then your 3D rendering in your mind is excellent. It's above average. And if you can work in these conditions, drawing it like that, then feel free to do that because it probably is a bit quicker and it gives you a bit more of a chance to see where, what don't I have, what do I need? Obviously in this one, like I said before, this is the side we obviously need because that's what we don't have in the last triangle. So it sort of helps you in that way, but it can get a bit squishy. So stick with what works for you. If that looks really complex, do the 2D stuff. If you feel comfortable with this, then feel free to go ahead with that method.